Hello everyone, I'm Big Cat. In this lesson, I'm going to create an animation montage related to using objects. First, create a standing use object animation montage file. Right-click on the AS stand use object animation and select Create Animation Montage. Double-click to open the file. Modify the slot to upper body. Reopen the file, and the animation displays normally. We can see that this animation is a looping animation. This animation is used for all the objects used. Each item takes a different amount of time to use. So this animation is a looping animation. Next, set this animation to loop in the montage. By default, there is only one session of this animation. So let's make this session loop. Click this button. Select default. This will keep looping this default session. Since use the item animation montage requires looping, there's no need to create a play end event. The logic controls to stop the animation from playing. Save. Close the file. Next, create a montage of using object animations in the crouch position. Right-click the AS Crouch Use Object Animation and select Create Animation Montage to open the file. Modify the slot to upper body. Reopen the file, and the animation displays normally. Click this button. Select Default. Save. Close the file. Next, create a montage of objects emitted in the prone position. Right-click the AS Prone Use Object Animation and select Create Animation Montage. Modify the slot to upper body. Reopen the file, and the animation displays normally. Click this button. Select Default. Save. Close the file. Move the animation montage file to the montage folder under Character. That's it for this lesson. Thanks for watching, and we'll see you next time. Hello everyone, I'm Big Cat. Starting in this lesson, we're going to start making character-based functions. In this lesson, we'll start by building the character-based component. Open my character. Open the viewport window. As you can see in the components window, there are 4 components by default. The first component is the capsule component, representing the character's border range and is primarily used for collision detection. In general, the capsule should wrap around the entire character model. The second component is the arrow component, which is used to indicate the character's current direction. This component is used when you need to get the current direction of the character. The third one is the skeletal model component, which shows the skeletal model of the character. The last component is the character movement component. This component controls the character's movement behavior. These components will be set up later in the course. First, let's set up the skeletal model associated with the character. Select the Mesh component. Set the skeletal model to SKM female in the Details panel. Once you are done with it, you can see the character model displayed in the viewport window. Here, you may ask why the middle part of the character is transparent. Here we have used a mask. We will dress the character later in the session on making costumes. Set the Z-axis rotation to minus 90 degrees. Once set, the character can be seen in the viewport window with the arrow pointing in the same direction. Currently, the capsule body doesn't not completely wrap around the character model, and the capsule body size needs to be modified. Select the capsule body component. In the Details panel, find half the height of the capsule body. This value represents the capsule's height value from the center to the top or bottom of the capsule. Modify this value to 97. In the viewport, the window sees that the character's head is still outside of the capsule body. However, we see that the character's feet are not at the bottom of the capsule. Select the mesh component. Set the Z-axis value to minus 97.6. This time again, we see that the character's feet are aligned with the capsule's bottom. Next, set the animation class used for this skeletal model. Set the animation class to ManAnime Blueprint. In the viewport window, you can see the skeletal model starting to play a standby animation. Compile and save. In this lesson, we have set the default component in character. That's it for this lesson. Thanks for watching, and we'll see you next time. Hello everyone, I'm Big Cat. In this lesson, we create camera-related functions. In the game, the window presents the content that is displayed by the camera. The camera represents the player's perspective. Before we create the camera, we will create a spring arm. The spring arm is used to automatically retract the camera's position when it hits a geometric object with a collision. This effect will be demonstrated to you later in the lesson. Select the capsule body because we want to create the spring arm underneath it. Click Add Component to create a spring arm. In the spring arm assembly, create a camera component. Select to run as a new window. You can see that what is currently displayed in the viewport where we just created the camera. Next, adjust the camera position. Since the camera is hanging below the spring arm, we only need to adjust the spring arm's position. Select the spring arm. Set the length of the arm to 200. This length is the distance from the camera to the character. Set the height of the spring arm to 100 and 25 to the right. Run. You can see that the character's position is adjusted by default after running. Since we haven't made the character movement and viewport movement yet, we can't do it yet. Compile and save. That is for this lesson. Thanks for watching, and we'll see you next lesson. Hello everyone, I'm Big Cat. In this lesson, we are making mouse control related functions. Pan the mouse to rotate the character left and right in the game, and the viewport will turn left and right. Moving the mouse up and down will cause the viewport to rotate up and down accordingly. Let's start by creating a mouse panning function. Open my character. Add a function. named mouse turn. This function will perform the logic of character rotation. Set the category to mouse input. Add input parameter named axis value. Set the tab to float. This parameter is used to receive the axis value parameter in the input event. Single right-click to create Add Controller Yaw input node. The purpose of this node is to add the rotation value, connect executes and connect parameters, compile and save. Next, make a response to the mouse panning event. Open my player controller. Open the full blueprint editor. We will often call functions from character in the controller. So get a reference to the character object at the start of the controller execution and store it in the controller for later use. First, get the current character from the getPlayerController node. Convert it to myCharacter. Promote the return value to a variable. Name it myCharacterRef. Add comments. Right-click in Event Graph to add the turn event. This event was created in the previous project setup class. Call the mouse turn function in character. Set parameters. Compile. Run the game. Move the mouse horizontally to see the viewport follow the mouse. We found a problem when the mouse is displayed by default when running, and you need to click the on-screen mouse to start controlling the character. Let's deal with this problem. Call the Set Input Mode Game Only node when the controller starts executing. Set player controller as self. Run it again. You can see that the default mouse is not displayed, and you can start controlling the character directly. Next, create the viewport move up and down logic. Open myCharacter. Add a function named mouseLookup. In this function, the logic for moving the viewport up and down will be executed. Set category to mouse input. Add an input parameter named axis value. Set the tab to float. This parameter is used to receive the axis value parameter in the input event. Create the Add Controller Pitch Input node. The purpose of this node is to add the rotation value, connect the parameter, compile, and save. Next, create an event that responds to the up and down mouse movement. Open myController. right-click on the event graph to add the lookup event. Call the mouse lookup function in character. Set the parameters. Compile. Run the game. Moving up and down the mouse character does not cause any reaction. Select the spring arm component. Check Use Pawn Control Rotation. Run the game. The viewport can already be changed by moving the mouse up and down, but currently the viewport moves in the opposite direction to the mouse. Open my player controller. Multiply the value by -1 and then set it to the function. Run the game. Move the mouse up and down. You can see that the viewport follows the mouse, but I think the viewport is following the mouse too fast. How fast the viewport moves depends on input access value. Change the viewport by multiplying by a number as you move the mouse up and down. Multiply by -1 to multiply by -0.5. Run the game. Now move the mouse, and the viewport moves much more comfortably than before. Add comment. Compile and save. That's it for this lesson. Thanks for watching, and we'll see you next time. Hello everyone, I'm Big Cat. In this lesson, we're going to create a character movement related function. Open the event graph of my player controller. Add function named moving on the ground. Here, we will complete the logic related to moving the character on the ground. Move is divided into backward and forward and left and right. There needs to be a parameter to distinguish the direction of the move. Add a parameter named forward. Of type Boolean. This parameter is true if the move is forward or backward, otherwise it is false. Add a parameter named access value of type float. A keyboard event moves the character. This parameter is access value of the keyboard event. If this value is 1, then the WOD key is pressed. If this value is -1, it means that the SOA key is pressed. If the value is 0, the key was not pressed to move the key. First, we get the controller's rotation value. We only need the direction value of the Z-axis. Create a rotator and set only the Z value. With this rotator, we get a forward vector and the right vector. The forward function determines the direction of movement. The add movement input node is called where my character. The purpose of this node is to increase the movement speed of the character. Set the direction according to the judgment. Set the scale value. For better readability of the blueprint, change the input parameters to local variables. Then use local variables. Compile, save. Next, make the response move event. Go back to event graph. Create the move forward event. Create the move right event. Call the moving on the ground function separately. Set access value separately. Check the forward parameter when moving forward. Add comment. Run the game. Press WOS key to move the character forward or backward. Press A or D to move the character to the left or right. Careful students may note that the character animation is not working when moving backward, which is caused by not adjusting the movement speed correctly. This will be addressed later in the lesson. That is for this lesson. Thanks for watching, and we'll see you next lesson.